point for angles and their measures. So the first problems want us to name the vertex and the sides of the angle. I'm going to just do an example first, and then we'll do one because there's only 3 of these. So if you have something like this, an angle, and this is L, this is M, and this is N, then our vertex is going to be L. And then my 2 sides are going to be LM. And we put the symbol for array over them, and LN. Now, the one that they give us is number 18. It's actually a straight line, and it has N, E, and K. Now, this obviously is a straight line, but it also is an angle. It's a straight angle, okay, because it's equal to 180 degrees. So my vertex on this one would be N, and then my sides are NK and NE. Next problems want us to write 2 names for the angle. So pretty much all angles can have 3 different possible names because of the order that we write them in. So you just have to pick 2 of them to call this. So 22. We have T here, P here. Oh, that's not a P. There we go. And S here. So I need to come up with some names for this. Anybody have one? PTS, that's one. Angle PTS. What else? It's another option. STP. And what's the last option? Just out of curiosity. Yep, just angle T. Since there's nothing else in this one, so if this had like another ray coming out of this, then we couldn't call it angle T, but because it's just one angle by itself, we can call it angle T. So as long as you have 2 of these, if you want to write all 3 for practice, you can, but as long as you have 2 of them, you're good. Okay. The next ones are using a protractor. Let me see how many we have. Does anybody have one? Just out of curiosity. Because I genuinely don't know how many are in here. Oh, I might actually have enough. Alright, just take one and pass it. It doesn't matter which one. So I'm gonna basically just make an angle here, and I'm just gonna basically tell you to make one that looks similar to it so that we can do it on our paper. But let's go. It's gonna look like number 24 for the moment. So we've got point Y, and then we have rays coming off of it like this. And this is X, and this is Z. All right, so it doesn't matter if yours looks exactly like this. Everyone's is going to be a little bit different. But you have your protractor, okay? It has the numbers going in both directions because right now, the way I'm holding mine, all my numbers are backwards. So they do it this way so that no matter which way you're holding it, you can read it. So you're going to take it, and there is a little dot in the middle at the bottom, or at least there should be. If I can, I'm just going to slap this down. So you want to line up your vertex in that little dot that's the hole in the middle of your protractor. If I can even pick it up. Okay. So there's like a hole down here. Does everybody see that? Does everybody's have a hole in it in the bottom on the straight part? Or at least like it may not have a hole, but like a dot where you can see where it's like a starting point.
I guess, yeah.
Okay. It should have something, or like a line that's coming down through the middle that shows you it's the center. Something. Okay. So you're going to line that up on the straight part of your angle. And then we're looking for where this is intersecting here and how many degrees. So I'm starting on mine from down here. So that means that I'm going this direction on mine. So 10, 20, 30, 40, 50. It's a little bit bigger than 50. Okay, now I'm not expecting it to be exact. Yours may be different than mine. Well, I'm sure it is because I guarantee we didn't draw our angles exactly the same. And so I'm just going to attempt to extend it out here as much as possible. I would say that's about 55. Okay, there with the tick mark. So I would call this a 55-degree angle. So the measure of angle X, Y, Z is equal to 55 degrees.
I'm confused on how you do it. Like, the little dots right here, is that where I'll put my line, my shoulder line?
Yeah, so basically it doesn't really matter. I could also do it this way. So I could turn it and start from over here. I just have to then start and use this side, 10, 20, 30, 40, 50. And either way you do it, you should get the same angle measure. It's a little easier if we do one, well, just for fun. Is this acute, right, obtuse, or straight angle? Acute because it's less than 90, so it didn't ask for that, so that's just bonus. Let's do another one. If we have an angle like this, I'm gonna make this A, B, C. Probably, we're gonna measure it, make sure. All right, so you can line this up either way. I'm going to line mine up down here. So I'm making sure that my line down here is lined up on top of this ray of my angle. So you got to watch where you're starting from. So I'm starting from over here. So I'm using this inner set of numbers. Okay, they got to go in numerical order. So I'm going all the way around till I get over here. So it looks like it's just less than 110. I'd say it's like 106 degrees for mine. Yours obviously might be different. So the measure of angle ABC, I could call it CBA, whatever you want to call it. Well, within reason, there's 3 options. Would be 107 degrees. Now, if you're a degree or 2 off on a problem on a quiz or a test, do you think I'm going to take points off?
Yeah.
No. Okay? Now, if you told me that this is 120 degrees and it's clearly less than 110, probably not going to give you all the points, right? But if you're close, that's what I'm caring about, right? You're not going to be like drawing your own angle. You're just going to be given one and you would be having to say what it is, okay? Let's see. Next is to use the angle addition postulate to find the measure of the unknown angle. So 26. The measure of angle ABC is equal to, and that's what we're trying to solve for. They give us a picture. That's not what it looks like. That has something like this, basically. This is C, this is B, A, and D. And they tell us that this angle is 60 degrees and this angle is 45 degrees. So the angle addition postulate, just like our segment addition postulate yesterday, says that for the measure of angle ABC, it's equal to the measure, in this case, of ABD plus the measure of angle CBD. Okay, or I could call it DBC. We just need to add an S, yeah. Okay, so that means that this is angle ABD is 45 degrees plus this angle is 60 degrees. So what is the measure of angle ABC?
100 degrees.
Yep, 105 degrees. Now, this next one's a little bit interesting because they give us, or they want us to find the measure of angle PQR. But they give us this angle here. That's not a good, hold on. Whatever, it's close enough. This is Q. Moving. This is P. This is S, and then we have another little teeny tiny angle over here. And there's R. Now, we have to watch really carefully with what they give us, okay? The angle in here is 20 degrees. But if they draw something like this, and then they write 160 degrees, what do you think that means?
But they're on 160 degrees combined.
Yep, so everything combined is 160 degrees. Okay? So, I'm trying to find, right now, this PQR angle, right? That's the angle that I'm trying to solve for. So, what would my angle addition postulate be for this problem in letters, not with the degrees in it yet? How would I write it? A measure of what?
SR plus P angle PQS minus angle PQS.
Nope. Angle addition postulate doesn't have a minus sign in it. So what's the big angle?
PQS.
Okay, so the big angle is equal to what?
SR plus RP.
Gotta give me all three. So SQR is the measure of SQR. We gotta say all three letters. Plus the measure of RQP. Okay, now I know SQR is 20. So now I can use this and I can plug this in. I also know that PQS is 160. So I'm just going to have to take this and solve this like an algebra equation now. So I'm going to subtract the 20. I don't know why I just put a dollar sign there. 140 degrees is equal to the measure of angle RQP. And that's my answer for that one. Okay, so you should be showing the segment addition angle addition postulate in use, okay, before you just give an answer. Okay, I recognize that you may just see that it's 140 degrees because you're probably like, yeah, well, 160 minus 20 obviously is 140. Okay, but you got to show it because that's what the whole point of this problem is. It's getting you used to using this stuff because later on when we start doing proofs in a couple chapters, you're going to need it to be able to do that kind of stuff, okay? Okay. Thinking about how much time we have left. All right, let's go ahead and do this. I think we have time to do this and what else I want to do. All right, draw a sketch that uses the following information. D is in the interior of angle BAE. E is in the interior of angle DAF. F is in the interior of angle EAC. The measure of angle BAC is 130 degrees. The measure of angle EAC is 100 degrees. And the measure of angle BAD is equal to the measure of angle EAF is equal to the measure of FAC. So then we're going to use that to find different things that they are asking us for. So, any ideas on what I might need to do to start with? This problem's going to require a little bit of thinking.
Maybe start with EAC, because you know F's in there, and you know the angle of EAC.
Yep, I know the angle of BAC, and I know that F is in there, so I'm not going to make it be like exact, but basically I know that 130 degrees is bigger than 90 degrees, so I'm just going to kind of eyeball it here. So right now I'm going to call this B, this is A, and this is C. Shouldn't matter which one I call it. Okay, I know A has to be in the middle because A has to be the vertex because A is in the middle of every single angle name, right? All right, so I've already dealt with that. Now, what else do I know?
EAC is 100 degrees.
Yep, so I'm going to go back and swap these letters because it'll just make it easier. Because this is 100 degrees, so it needs to go just a little bit above this. So I'm going to swap B and C. So I'm going to make this C and this B. So I'm going to put my next thing in. I forgot to put my arrows on here. I'm going to put the next thing in here. So this is going to be E. So EAC is now 100 degrees. So I know also that E is in the interior of DAF, right? F is in the interior of EAC. So where does that mean that F needs to go?
In the EAC,
Yep. Do I know what it's equal to though? No, so I'm just gonna put it in here somewhere. Call this F.
can you move that down a little bit?
I also know, let's see, I've got E and F on there. So I just need to do D. D is in the interior of BAE, so where is D going?
Between B and E.
Yep. So, this one. So D is somewhere in here. Now, I know that, that's D. I know that BAD is supposed to be equal to EAF, and that's equal to FAC. So, I probably don't have a super accurate picture right here, right now. But it's close. That's all we're going to do with that is setting it up. This goes with problems 29 through 34. We may come back to this, but that's all we're going to do with that right now. But I just want to make sure that we can like draw it, basically. Okay. And there's other things that are more important in here right now. Okay. I'm trying to see. I don't think we're going to get through everything I want to get through. All right, in a coordinate plane, plot the points and sketch angle ABC. Classify the angle and write the coordinates of a point that lies on the interior of the coordinates of a point and one that lies on the exterior. So basically, I'm going to have a graph. Doesn't have to be on graph paper. If you want it to be, that's fine, but it doesn't matter. All right, so they tell us A is 3, -2, B is 5, -1, and C is 4, -4. All right, so on here we are going to plot these points. So A is at 3, -2, so that means come over 3, down 2. So that's A. B is at 5, -1, so go over 5, down 1. And C is at 4, -4. And I'm looking for angle ABC. So I'm going to connect these dots here to make an angle. It's angle ABC, so B has to be my vertex. So I need a coordinate that would be inside of this angle here. Can anybody give me one?
4, -2.
4, -2. Yep.
3, -3.
Yep, 3, -3 would work. There obviously are going to be a lot. What about an exterior point? So one that's outside of it.
-5,
3,
6.
+4.
-5.
What other one did you say?
+1. 100.
Oh. Yep. So obviously lots of them that can meet that criteria there. All right. We might do a little bit more with this section on Monday. We might go back to that problem. I might try to make a better diagram for you and then like actually print it out and give it to you if we're going to do anything else with that. But there's a few more things in here that I think we might need to look at before the quiz. So plan on the fact that we may have a quiz on Tuesday if I decide not to do anything else with this section. But just know that it may be shifted to Wednesday once I decide for sure if there's enough to like warrant doing another whole day on this stuff. So your problems so far that are due, I'll make them due Monday since you have your theorem and postulate book due tomorrow, and since I won't be here tomorrow. 17, 19, 21, 23, 25. So these two you need a protractor for. So I'm going to leave the box up here. These don't go home with you. They stay here. But I'll leave the box up here so if you work on the problems tomorrow or whatever, you can do those two in class. 27, 35, 37, and 41. All right, so remember tomorrow you need to work on your vocab book in class and these problems. It's like either 52 or I think it's 52 vocab words are due Monday. And then sometime next week we'll have a vocab quiz on those things. So I would start studying those as well while you're writing them. Hopefully some of them you're getting familiar with as we're using them. And remember, if you don't have that theorem and postulate book turned in tomorrow, you do not get to use it on the quiz or the test this entire chapter. Okay? Yes.
You said you don't care if we do the paper bag for the books.
Yeah, that's fine. Yes, and books, a lot of you don't have book covers. You need to do that.
Did you say the vocab quiz is next Friday? Or did you say?
I just said it's going to be sometime next week. But it probably will be Friday, but that's not 100% set. But yeah, probably.
Protractor.